Hello everyone. Today I am here again with you all with a new topic of mathematics, that is coordinate geometry. In our previous classes we have already learned that if we want to locate any point in any plane, then we want two coordinate axes. So these two coordinate axes which we are taking as the base are the x-axis, this is the x-axis, and this is the y-axis. These two axes we are taking for locating any point in a plane. Suppose the point is, this is the point, this is your point A, then the distance of this point from the y-axis, this is your x-axis, that could be written as x dash, and this is the y-axis, over here y and y dash. This is the origin denoted by O. Now this is a positive x-axis. If we will be taking the points over here, it will be positive numbers, unit distance, and these will be the negative numbers, negative y-axis. Over here upside it is positive y, like this, and in the downwards direction it is your negative y. So this is how we can locate the points. Now suppose we have taken the point A. So distance of this point from the y-axis is known as its x coordinate. That means this distance is its x coordinate, and this x coordinate is even known as abscissa. Similarly, the distance of this point from the your x-axis is your y coordinate. This distance from the x-axis is known as its y coordinate, and this y coordinate is even known as ordinate. So whatsoever the point we are taking, its distance from the y-axis is known as its x coordinate, and its distance from the x-axis is known as its y coordinate. Suppose the point over here is, the coordinates of this point is x comma y. Whenever we are denoting any point in terms of coordinates, always we are writing it in the small brackets. The first will be its x coordinate, then comma will be there, and then it will be the y coordinate, and then we will close the bracket. This is how we are writing coordinate of any point. Now if we are going to see over here, if we are going to take one point as 2 and another point as 4 on the x-axis, whenever we are taking any point on the x-axis, its y coordinate are always 0. So coordinate of this point will be 2, 0 because it is on the x-axis. The coordinate of this point will be 4, 0. Similarly, if we are going to take any point on the y-axis, then its x coordinate will be 0. That means if we are taking this as the point and we are taking this as the point, then the coordinate of this point will be 0, 1, and coordinate of this point will be 0, 4. So whenever we are taking any point on the x-axis, its y coordinate will be 0, and whenever we are taking a point on the y-axis, its x coordinate will be 0. Now let's see if we have to find distance between these 2 points. If these two are the points and we have to find distance between these 2 points, we can easily say that this distance will be 4 minus 2, that is your 2 units. It's very easy to calculate it. If we are going to find distance between these 2 points, easily we can say that the distance between these 2 points is 4 minus 1, that is 3 units. Similarly, suppose if there is a point this minus 3 and the another point is your 1. If we have to find distance between these two, so we can see here from 0 to minus 3, it is your 3 units, and from 0 to 1, it is your 1 unit. So total it will be 4 units. So if there are any points given on either the y-axis or on the x-axis, it is very easy to calculate the distance between these 2 points. Now suppose your point is this is the point. If this is the point, how to find the distance of this point from any other point? That means for finding distance we require 2 points. So suppose if I am taking again the same, if this is one of the point, that is your 3, 0, and this is the point 0, 4, and we have to find distance between these 2 points, then what will be the distance? This could be the distance. This will be the distance, and we can see it is forming a right angle triangle, where this is your base, this is your perpendicular, and this is the hypotenuse. And we know in a right angle triangle, by Pythagoras theorem, we can find the distance. Hypotenuse we can find by Pythagoras theorem. Over here we can see that from here to here, 0 to 3, it is your 3 units, and from 0 to 4, it is your 4 units. So if this is your 3 units and this is your 4 units, we can find your hypotenuse. So hypotenuse, suppose it is your point P and it is your point Q. So PQ square will be OQ square plus OP square by Pythagoras theorem. That means OQ will be your 3 square, and OP is your 4, so it will be 4 square. So 3 square will be 9, square of 4 will be 16, and this is the value of PQ square. That means PQ will be root of 25, that you can say 5 units. So if one of the point is on the x-axis and one of the point is on the y-axis, again it is very easy for us to calculate the distance between the two. But if this is not the case, if the 2 points which we have to find the distance between, both the points are lying in any plane, not on the x-axis and not on the y-axis, then how to find the distance between these 2 points? So let's see, suppose I am taking again, this is your y-axis, this is your x-axis. Suppose this is one of the point and this is another point. These two are different points and we have to find the distance between these 2 points. Now this is your x coordinate, x-axis, and this is your y-axis. Suppose this and this, from here, from the points we have drawn the perpendiculars on the x-axis. This is your 0, this is 1, this is 2, this is 3, this is 4, this is 5, suppose. And if we are going to draw perpendicular from here and we will join this, we want basically the distance between these 2 points, that means we want this. And if we will see that again it is forming a right angle triangle. Now we can see from here that the coordinate of this point, x coordinate will be your 3. We will be checking what the y coordinate will be. And suppose if we are going to see from here, this is perpendiculars we have drawn from here and perpendicular we have drawn from here. Suppose this is your 1, this is your 2, this is your 3, 4, 5 and 6. So y coordinate will be your 3 again. This is x coordinate 3 and y coordinate will even be 3 for this point. If we will see this point, so x coordinate will be 5 and the y coordinate will be 6. So once we are having the coordinate of 2 points, we have to find the distance between. How we will be finding it? We can see that over here this is 3 and this is 5. So distance between these two, is your 2 units. That is your 5 minus 3, it is your 2 units. And distance between these 2 points, this perpendicular distance, we can see it is your 3 here and it is your 6 here. That means this distance is your 6 minus 3, that is your 3 units. How we can find it out? Just subtract from this x coordinate 5 minus this x coordinate. 5 minus 3, it will give you 2 units of the x coordinate. And over here, y coordinate was 6 and here y coordinate was 3. So 6 minus 3, it is your 6 units, 3 units. So if this is your 3 unit and this is your 2 units and this point is A and this point is B and this point is C, then AB square will be equivalent to AC square plus BC square by Pythagoras theorem. So we can see AC is your 3 units, that is 3 square, and BC is 2 units, so square of 2. That will be 3 3s are 9 and 2 2s are 4. It will become 13 and the value of AB will be root of 13 units. This is how we can find the distance between 2 points if they are not on the either of the x-axis or y-axis. Now if we have to find the general formula for finding this, so we can find it out. Again I am checking the 2 coordinate axis. This is your x, this is x dash, this is y and this is y dash. It is the origin. Now the 2 points which I am taking is over here. It is, we have to find this distance. Suppose this is your point A and this is your point B. Again, I'll be drawing the perpendicular from here. Now suppose the coordinate of this point is x1 comma y1. X coordinate is x1, general I am taking, and y coordinate is y1. Similarly, for this coordinate, this point, the coordinate x coordinate is x2 and the y coordinate will be y2. So distance between these two, suppose this is your C point. So value of BC will be, as just now we discussed, BC will be x2 minus x1. It will be x2 minus x1 units will be the distance of your BC. Similarly, AC will be y2 minus y1. AC will be your y2 minus y1. Now we have to find the value of AB. Length AB we have to find. So by Pythagoras theorem we can say AB square will be AC square plus BC square. Now value of AC we know it as y2 minus y1 whole square and BC is your x2 minus x1 whole square. That simply means value of AB means length of AB will be root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the general formula by which we can find the distance between any two given points. This formula, by this formula, and this is known as your distance formula. So by this distance formula, if there are 2 points given in any plane, then we can find the distance between these 2 points. Let's take an example. Suppose the coordinates of point A is your 4, 2 and coordinate of B is 5, 7. So here if we are going to compare, this is your x1, this is your y1, this is your x2, this is your y2. So distance between AB, that is AB will be root of x2 minus x1 whole square plus y2 minus y1 whole square. 5 minus 4 whole square plus 7 minus 2 whole square. This will be the distance between these two. We can solve it further. So it will be 5 minus 4 will be 1. Square of 1 will be 1 only. 7 minus 2 will be 5. 5 square will be 25. And that will be root of 26 units will be the distance between A and B. We can find it out very easily. Here we should know that either we can take this as x1 y1 or this as x1 y1. The answer won't going to change. It is not going to change. It will remain same. Whichsoever point we can take it as x1 y1 and another point we can take it as x2 y2. So there won't be any change because we are doing the square of it. So whatsoever it is, if you are doing 4 minus 5, it will become minus 1 and a square of minus 1 will be your 1 only. And if you will be doing 2 minus 7, so it will be minus 5 and a square of minus 5 will be 25 only. So whatsoever you are taking this, either take this as x1 y1 or take this as x1 y1. So their answer is not going to change. It will remain same. Now the coordinate of your origin. We can see the coordinate of the origin will be your 0, 0. It will be 0, 0 if you have to find distance of any point from origin. Suppose a point is given to you. Suppose P is a point and the point coordinates are your minus 2, minus 3. X coordinate is minus 2 and Y coordinate is minus 3 and you have to find its distance from the origin. Origin is your 0, 0. So OP will be, suppose I am taking this as x1 y1 and this as x2 y2. So using your distance formula only we can find it out. What it will be? X2 minus x1 whole square plus y2 minus y1 whole square. So it will be minus 2 whole square, that will be 4, and 3 minus 3 whole square, that will be 9. So root of 13 units will be distance from origin. So over here, if we are going to replace this x1 by 0 and this y1 by 0, it will give us the distance from the origin. If there is any point in the plane, so the distance of the plane, your point from the origin will be, it will be your x square plus y square. If the coordinate of the points is your x and y. X comma y is the coordinates of any point lying in any plane, then its distance from the origin will be given by root of x square plus y square, because one of the coordinate, either x2, y2 or x1, y1 will become 0 in this case, because coordinates for origin is 0, 0. So this is how we can find distance between any two given points in the plane if they are on the x-axis, if both are on the y-axis, if one is on the x-axis, one is on the y-axis, if both of them are on the plane, neither on the x-axis nor on the y-axis. So using this method, we can find the distance between any two given points in the plane. Just now we have seen if there are any 2 points given in the plane, then how to find the distance between these 2 points. Now let's see what is section formula. Suppose there are 2 points in the plane. This is your point A and this is on the point B. A line segment is there and the endpoints of these 2 line segment is your A and B, and these are the endpoints of a line segment. Suppose the coordinate of this point A is x1, y1 and the coordinates of this point B is x2, y2. And there is a point between these two, anywhere between these two. Suppose this point is your point P and the coordinate of this point is your x, y, which we don't know. We have to find its value, what the value of x and y will be. If we know that this point P is dividing this line segment AB into the ratio m1 is to m2, the ratio in which this point P is dividing the line segment AB is suppose m1 is to m2. If we know the values of x1, y1, if we know the value of x2, y2, and if we know the value of m1 and m2, then we can find the value of xy. We can find the coordinates of this point P, which is dividing the line segment AB into the ratio m1 is to m2. What is the meaning of m1 is to m2? It is dividing it into, that simply means the length of AP to PB. That simply means your AP upon PB, it is equivalent to m1 is to m2 also. Right? Now, what will be the values of x and y? So, formula for finding this is, value of x will be m1 multiplied by x2. This m1 will be multiplied by x2. So, it will be m1 x2 plus m2 will be multiplied by x1, m2 x1 divided by m1 plus m2. This will be the value of this x coordinate. Now what will be the value of this y coordinate? So y will be m1 into y2, m1 will be multiplied by y2 plus m2 into y1 divided by m1 plus m2. So this will be the values of the coordinates of the point P. This is the x coordinate of P and this is the y coordinate of P. Using this formula, we can find the value of the coordinates of the point which is dividing the line segment AB into the ratio m1 is to m2. Now suppose I am taking an example. Suppose these are the line segment AB. The coordinate of point A is 2, 7 and the coordinate of B is 3, say 4. These two are the points. Now we have to find the coordinates of the point P which is dividing it into the ratio 2 is to 1. Here value of m1 is 2 and value of m2 is 1. Now what the coordinate will be? Suppose the coordinates are your x, y. So value of x will be 2 multiplied by 3 plus 1 multiplied by 2 divided by 2 plus 1. This will be the x coordinate and its value will be 2 multiplied by 3 will be 6 plus 2 over 3, that is your 8 by 3. Now the y coordinate will be 2, 2 will be multiplied by this 4, 2 multiplied by 4 plus 1 will be multiplied by 7 divided by 2 plus 1. 2 multiplied by 4 will be 8. It is 7 over 3. That is 15 over 3, or we can say it as 5 also. So this will be the coordinate of point P, that is 8/3, 5. So this is how we can find the value of the coordinates of the point which is dividing a line segment into the given ratio. So this is the formula. This is known as your section formula. This is section formula. Now the special cases of this section formula will be taking. Suppose instead of two variables, over here there are two variables. If we have to find the values of m1 and m2, if there are two variables, if we want to take only one, that means if it is asked in what ratio it is dividing, this point is dividing it into what ratio. So in that case, what we will be doing, instead of two variables, we will be taking only one variable. We can take, if this is the points A and B, and there is any point P which is dividing this line segment AB into the ratio we will be assuming is to K is to 1. Instead of M1 is to M2, we will be assuming it to be K is to 1, because it is always better to take one variable instead of two variables. Suppose the coordinates of point A is your x1, y1 and B is your x2, y2, and the coordinate of P is your x, y. So x will be, in this case, x will be k multiplied by x2. So k into x2 plus 1 multiplied by x1 over k plus 1. This will be the x coordinate, and the y coordinate will be k multiplied by y2 plus 1 multiplied by y1 over k plus 1. So instead of taking two variables, we can take it as one variable only. In that case, we can take it as it is dividing, P is dividing the line segment AB into the ratio K is to 1. Now the special case, that means if your point P, the point which is dividing this line AB, line segment AB, it is dividing into two equal halves. That means it is the midpoint. If it is a midpoint, then we know that it is dividing the line segment into the ratio 1 is to 1 only, because it is the midpoint. That means the ratio between these two, that means AP will be equivalent to PB, and if AP and PB both are equal, that means it will be, the ratio in which it is dividing will be your 1 is to 1 only. So if it is a midpoint, for midpoint your ratio will become M1 is to M2 will be your 1 is to 1. And in that case, now here, if these are the points and we are taking the point which is dividing it into the ratio 1 is to 1, the coordinate of A is x1, y1 and the coordinate of B is x2, y2. Coordinate of P is x, y. In that case, x will be 1 multiplied by x2 plus 1 multiplied by x1 over 2. And y coordinate will be 1 multiplied by y2 plus 1 multiplied by y1 over 2. That means when a point is dividing into two equal halves is the midpoint, then the coordinate of the point, that point will be x1 plus x2 by 2, y1 plus y2 by 2. This will be the points. This will be the coordinate of the point. Now suppose instead of 1 is to 1, suppose it is condition is given that it is a trisection is there. That means there is a line A and B. These type of questions are even there in the exercise. If there is a line segment AB, the coordinate of A is suppose x1, y1. The coordinate of B is x2, y2. In between there are 2 points, because trisection is there and it is equal trisection. That means it is dividing in 2 points will be there, and these 2 points will be dividing this line segment AB into 3 equal halves. So one of the point we will be assuming to be P and one of the point will be your Q, suppose. That simply means AP will be equivalent to PQ will be equivalent to QB. This will be the condition, because 3 equal parts it is dividing it into. That means P and Q, these 2 points will be somewhere in between A and B, and such that your AP will be equivalent to PQ will be equivalent to your QB. Now here we can see that this point P is dividing the line segment AB into the ratio 1 is to 2, because AP is equivalent to PQ is equivalent to QB. That means PB part is 2 parts and AP part is 1 part. That means P point is dividing this line segment into the ratio 1:2. And this Q point is dividing the line segment AB into the ratio 2:1. It must be clear that 2 points we have to take, and these 2 points will be dividing the line segment into 3 parts. One is your AP, then your PQ, and then your QB, and these 3 are equal in measurement. So AP is equivalent to PQ is equivalent to QB. That means P is dividing the line segment AB into the ratio 1:2. So M1:M2 is your 1:2, and Q is dividing the line segment AB into the ratio 2:1. So this is how we can find the coordinates of your P and Q, because we know the values of M1:M2. So using the section formula, we can find the coordinates of P and Q. So this is how we can use your section formula for finding various points on the line segments. Now let's see what is centroid and how to find the coordinates of a centroid of a triangle. The intersection points of the medians of a triangle is known as centroid. Means the point where all the 3 medians of a triangle will meet, that point is known as centroid. Here we have taken a triangle ABC. The coordinates of point A is x1, y1, B is x2, y2, and C is x3, y3. AD is the median from the vertex A on the side BC of the triangle. Median means the point which is intersecting the opposite side. That means from A vertex, if we are going to draw the median, it is going to bisect the side BC. That means D will be the midpoint of BC. Now, if from the point B, I'll be drawing the median on this point, on this side AC, that means from here, this will be the median, and from here, this will be the median. So the point where all the 3 medians of a triangle meet, that point is known as centroid of the triangle. Now suppose we are saying that the coordinate of your centroid G is your xy. Now how to find the value of your xy? This is one of the property that median, the centroid divides the median into the ratio 2:1. Now here suppose we are taking, the given is a triangle is there, a triangle we have taken ABC in which AD is median. If AD is median, that simply means BD will be equivalent to CD, because D is bisecting your BC. Now if D is the midpoint, that means coordinate of this point D. Just now we discussed how to find the coordinates of the midpoint of a line segment. So the coordinates of this D coordinate will be x2 plus x3 by 2. This will be the x coordinate of D, and y coordinate will be y2 plus y3 by 2, because this D point is dividing the line segment BC into the ratio 1:1. So by section formula, we will be getting the coordinates of D as your x2 plus x3 by 2 and y2 plus y3 by 2. This is the coordinates for the point D. Now we are taking this line AD, this line segment AD, I am taking it like this. Over here, this is the point G whose coordinates are xy. Now the coordinate of A is x1, y1, and the coordinate of D is x2 plus x3 by 2 and y2 plus y3 by 2. This is the coordinates for point D. Now this centroid is dividing the median into the ratio 2:1. By section formula, we can find the coordinates of x and y. So x coordinate will be 2 multiplied by x2 plus x3 by 2 plus 1 multiplied by x1, that is x1 only, divided by 2 plus 1. That is your m1 into x2 plus m1 into x1 divided by m1 plus m2. By section formula, we have find the value of x. Now, what the value of y will be? 2 multiplied by y2 plus y3 by 2 plus 1 multiplied by y1 over 2 plus 1. This will be the y coordinate for the point G, that is centroid of the triangle. Now the x will be, these 2's are going to cancel. The numerator part will be x1 plus x2 plus x3 by 3, and y coordinate will be, again 2 are going to cancel. It will be y1 plus y2 plus y3 by 3. So this is how we can find the centroid of your triangle. If we are having all the three vertices of a triangle, we can find the coordinates of the centroid using this formula. It will be x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. This is the coordinates of the centroid of the triangle. If the three coordinates of the triangle are given to you, if one of the coordinate is x1 y1, another is x2 y2, and third one is your x3 y3, then this will be the formula for finding centroid of the triangle. Now let's see some important points used for solving some important questions related to this chapter only. See, if there are four coordinates are given to you, a coordinate, that is your x1 y1, another coordinate x2 y2, third coordinate x3 y3, fourth coordinate x4 y4. If 4 points are given to you and you have to prove that the figure which will be formed by joining these 4 points will be a parallelogram. So for proving a figure to be parallelogram, we need to prove that the opposite sides of the figure whichsoever will be formed will be equal and the diagonals will be unequal. That means what we will be doing, we will be finding the length AB, we will be finding the length B, suppose this is your C and this is your D, A, B, C, D. So one of the side we have to find is your AB, another is your BC, then we will be finding the length CD and we will be finding the length AD. Along with that, we will be finding the length AC and BD. These 6 lengths we will be finding using your distance formula. That is your square root of x2 minus x1 square plus y2 minus y1 square. So using these formula, we will be finding these 6 lengths. If the length AB and CD is equal, that means these are the opposite sides. If the length of BC and AD is equal, they are even the opposite sides, and these diagonals are not equal, then we will say that the figure which will be formed by joining these points will be a parallelogram. That means for parallelogram, opposite sides should be equal and diagonals should be not equal. Diagonals should not be equal. If this is the condition fulfilled, then we will say that the figure which will be formed by joining these 4 points will be a parallelogram. If we have to prove that the figure which is forming by joining these your 4 points is forming a rectangle, for that case we have to prove that the opposite sides, that is AB, will be equivalent to CD. We will be finding again all the 6 distances. We will be finding distance of AB, BC, CD, AD, AC and BD. These 6 lengths we will be finding, these 6 distances we will be finding, and we have to prove that this opposite sides AB will be equivalent to CD, BC will be equivalent to AD, and your diagonals AC will be equivalent to BD. If these 3 conditions are fulfilled, then we will be saying that the figure which will be formed by joining these 4 points is your rectangle. Now, if we have to prove that it is a rhombus, in that case, we will be proving that all the 4 sides, that is your AB, is equivalent to BC, is equivalent to CD, is equivalent to AD. All the 4 sides are equal and your diagonals is not equivalent. diagonals are not equal in length. If this is the conditions we will fulfill, then we will say that the figure which will be formed by joining these 4 points will be a rhombus. If we have to prove that the figure which will be formed will be a square, for that we need to prove that all the 4 sides are equal. That means your AB will be equivalent to BC, will be equivalent to your CD, will be equivalent to AD, and diagonals are even equal. If this is the condition and it is fulfilled, then we will say that the figure which will be formed by joining these 4 points will be a square. Now, if we have to prove, if instead of 4 points, 3 points are there, if there are 3 points and we have to prove that the figure which will be formed by joining these 3 points is a right angle. If we have to prove that figure from joining these 3 points is a right angle triangle, in that case we have to prove that the square of the longest side is equivalent to the sum of the square of rest 2 sides. That means we will be, suppose these coordinates are your points are your A, B, C, then we need to prove that whichever is the longest side, the square of the longest side is equivalent to squares of rest 2 sides. Sum of squares of rest 2 sides. If we will prove this condition, then we will say that the figure which will be formed by joining these 3 points will be a right angle triangle. That means we will be proving simply Pythagoras theorem, that the length square of the longest side is equivalent to the sum of the squares of the rest 2 sides. Now, if we have to prove that the given 2 points are collinear. Collinear means that if all the 3 points, if there are 3 points given, so all the 3 points comes in the same line. If we have to prove that the given 3 points, suppose the points are your A, B and C, and we have to prove that these 3 points are collinear, for that we will be proving that the longest side, whatsoever will be the longest side, it is equivalent to sum of 2 smaller sides. That means for this what we will be doing, we are having coordinates of 3 points. Suppose one of the coordinate is of A, another is B, another is C. So we will be finding the length AB, we will be finding the length BC, and we will be finding the length AC. These 3 lengths we will be finding, and if the longest side is equivalent to the sum of the 2 smaller sides, then we will say that the 3 points are collinear. So these are some specific conditions. There are so many questions related to it that prove these are the coordinates of a parallelogram, prove these are the coordinates for the right angle triangle. So for this we have to prove all these conditions. For parallelogram, the opposite sides should be equal and the diagonals should not be equal. They should be unequal. For rectangle, opposite sides should be equal and diagonals should even be equal. For rhombus, all the 4 sides should be equal and diagonals should not be equal. For a square, all the 4 sides should be equal and diagonals should even be equal. For right angle triangle, square of the longest side should be equivalent to the sum of squares of rest 2 sides. That means 3 coordinates are given. We will be finding length AB, we will be finding BC, and we will be finding 3 lengths AC. And sum of the square of the longest should be equivalent to the sum of squares of rest 2 sides. Means the square of the longest side should be equivalent to the sum of squares of rest 2 sides. For collinearity, for if we have to prove that the 3 points, given 3 points are collinear, we have to find the 3 lengths, that is AB, BC and AC, and if the longest side is equivalent to sum of the smaller 2 sides, then we will say the 3 points are collinear. Now let's see what is equidistant condition. If we will be taking any 2 points A and B, and we have to find a point which is equidistant from these 2 points. Suppose the line segment is your AB, the 2 endpoints of this line segment is your A and B, and we have to find a point P such that the distance of P from both the endpoints is equal. That means PA is equivalent to PB. And we know that if we are going to take the perpendicular bisector of this line segment, so every point which is going to lie on the perpendicular bisector will be equidistant from both the 2 points. And suppose this is the perpendicular bisector and this is the point which is lying on the perpendicular bisector. This is even one of the point, this is even one of the point. So there are infinite of points are there which is lying on this perpendicular bisector, and every point is equidistant from both the 2 points, that is your A and B. That means if this is your point P, then PA will be equivalent to PB. If this is the point Q, then AQ will be equivalent to your BQ. That means whatsoever the points are lying on this perpendicular bisector, for every point, distance from this point to both the two endpoints of the line segment will be equal. If it is your point S, then AS will be equivalent to BS. So we can say if we want the line, means your equation for the perpendicular bisector, then it could be, if the point we are considering as P, so if we will equate PA is equivalent to PB, so whatsoever the equation we will be getting, that will be the equation for the perpendicular bisector. So how we can get it? If the coordinates of this is your A point is x1, y1 and coordinates of B is x2, y2. Coordinates of P is x, y. And if we will find the distance PA by the distance formula, we will find the length of PB, and if we will equate both of them, then whatsoever the equation will be formed, that will be the equation for the perpendicular bisector. And if PA is equivalent to PB, then we can say PA square will also be equivalent to PB square. If we are going to find the distance of PA, it will be root of x1 minus x whole square plus y1 minus y whole square. This is the distance PA. For PB, it will be root of x2 minus x whole square plus y2 minus y whole square. Now because PA is equivalent to PB, so we can say that PA square is even equivalent to PB square. So we will be squaring both the sides and we will be getting x1 minus x whole square plus y1 minus y whole square is equivalent to x2 minus x whole square plus y2 minus y whole square. If we will be solving it further, whatsoever the equation we will be getting will be the equation for this perpendicular bisector. That means by equating the two distances PA equivalent to PB, the point which is lying on the perpendicular bisector will be equidistant from the endpoints of the line segment. Now one of the more property of your parallelogram we will be considering. Suppose a parallelogram is given. Suppose this is a parallelogram, ABCD is the parallelogram, and three of the coordinates of the parallelogram is given to us. So how we can find the fourth coordinate of the parallelogram? Suppose this coordinate is your x1, y1, B coordinate is x2, y2, C coordinate is x3, y3, and we have to find the coordinate of D, that is your x4, y4 we have to find. Now we know that if we are going to draw the diagonals of a parallelogram, then they are going to bisect each other. This is the property of a parallelogram. That means from A and C and B and D, the point where they will be meeting each other, they will be intersecting each other, this will be the midpoint for AC also, and this will be midpoint for BD also. Suppose this point is your O and its coordinate is x, y. Now we are having three coordinates and we have to find the fourth coordinate. How we will be finding it? From A and C, we can get the midpoint of this AC. Its coordinate is x1, y1, its coordinate is x3, y3. So midpoint of this, that is coordinate of this O point, x will be x1 plus x3 by 2 and y will be y1 plus y3 by 2. By the midpoint formula, we can find the midpoint of A and C. That means O is bisecting AC into 1:1. By that we can find the value of coordinates for the O point. And once we are having the coordinate of O point from the diagonal BD, here we can see that O is the point which is bisecting BD into two equal halves. That means if we are having this coordinate and if we are having this coordinate, we can easily find the coordinates for D also. How we can do that? If we are taking this diagonal BD, so here also x will be equivalent to x2 plus x4 by 2, because x is this point, O is the midpoint of BD. That means this coordinate x will be x2 plus x4 by 2 and y coordinate will be y2 plus y4 by 2. From here we already know the values of x and y. Once we are having the values of x and y, we can keep these values over here. We know the value of x2 also. We know the value of y2 also. We know the value of x. We know the value of y. So once we are having all these values, we can easily find the value of x4 and we can easily find the value of y4. So this is how we can solve the problems. These are the concepts related to the problems in the exercises. I hope all these concepts are clear to you. Soon we'll be coming with the more videos with the questions related to this chapter and many more videos of 10th standard with other topics also. Hope you are liking the videos. Thank you.